Alright, this next topic we're going to talk about is systems of inequalities. Basically, we're going to start with looking at inequalities with two variables and their graphs, and then solving systems of inequalities where we combine more than one inequality in the same, or at the same time, solving them at the same time. Okay. So the main thing is we got to know how to graph these inequalities, and so I'm going to show you that first, a couple examples, and then we'll combine them together into a system. So the first one here I have written out for you is 3x plus 6y is less than or equal to 6. Now when we solve these inequalities, first of all, I'll just give you a couple general principles, and then we'll take a look at the details. The first thing is the line, the actual line, 3x plus 6y equals 6 is the boundary between the solutions and the non-solutions. Okay, between the solutions and non-solutions. Okay, so we're going to plot the graph of the line 3x plus 6y equals 6, and then on either side of it, on one side of it is going to be the solutions, and the other side is going to be all points that are non-solutions. So we'll explain more as I go, but we'll start with that fact. So first thing we want to do, actually, let's take this equation and let's find the x and y-intercepts real quick. That way I can plot this pretty quickly. So x-intercepts occur when y is equal to 0. So we get 3x, the y term disappears, equals 0, equals 6 here. Let's divide out the 3. X will be equal to 2. So that's our x-intercept is at 2, 0. Then the y-intercept, remember that is where x is equal to 0. So plug in the 0, whoops, we'll go to this one. Plug in the 0, the x term disappears, and you're just left with 6y equals 6. Divide out the 6's, and you get 1. So y-intercept is at 0, 1. Okay. So now I'm going to plot both of those points. Let's get a little graph going here. Okay. And let's just use a scale of 1 for these grid lines. So the first point, the x-intercept, is over here at 2. The y-intercept is up at 1. If I want to sketch the graph, it's going to go down 1 over 2, up 1, back 2, and so on. Okay, and we should get this line decreasing. Now that line is going to be the boundary. What's interesting is I want to make a solid line here. There's two different notations on the line. This one, I want to include the points that make the left and right hand side equal to each other, because there's an equal sign in my inequality here. And in order to do that, we're actually going to leave the line itself as part of the solution. So every point on the line, which is the boundary, remember, is itself a solution. And so I'm going to leave that solid. If it were the case that we did not have this equal sign here, if it was just a less than, then I would want to make this line a dashed line. A dashed line represents not including it as part of the solution set. Okay, so at this point I have the line drawn, but now I need to determine which side of this line down to the left or above and to the right contains all of my solutions. Now there's a trick to this. You can actually plug in any point on either side of this line and make a decision based upon that. It's called a checkpoint or test point. Okay, I'll call it a test point. Now I typically use the point 0, 0, the origin, because that's easy to plug in. The arithmetic is nice. You don't have to use that point. You could use any point. And in fact, you can't use that point if the line goes through it. But I'm going to be able to use it here because it is on one side or the other of the line. So if I plug in 0, 0, back to the original inequality, you get 3 times 0 plus 6 times 0. Let's see, on the left there, these things both add up to 0, so you just get 0. And now, does this satisfy the inequality? Is 0 less than or equal to 6? That's the question, and the answer is yes. Okay, that does work. So that means that 0, 0 is a solution, and if 0, 0 is a solution, then everything on this side of the line will also be a solution. And so, rather than testing every point, I couldn't, there's an infinite number of them, I can simply just shade in this entire region below and to the left of the line. Okay?